Okay, let's talk about graphing from an Algebra 2 perspective. So if you're given something like y equals x minus 1 squared times x plus 1, what we want to do is there's a couple things that we've discussed thus far that we can apply. The first is end behavior. So what do we know about the end behavior? Well, we know that as x approaches negative infinity, we know what f of x is going to happen with f of x. Okay? What we know is that what this is essentially saying is, well, first off, let's back up here. If this function is x squared, if we FOIL, we're going to start off getting an x squared, which will be the highest power. And then later on, we're going to have to multiply that by x. So this function is written as a cubic. In essence, this exponent is 2, this exponent is 1, or just because this is 1, we know 2 plus 1 is 3, hence it's a cubic. Okay? So, though I don't need to actually write out the entire function, I know this function is going to start off with an x cubed term. And the leading coefficient, though it's not written, is 1. So, the question is as x gets closer and closer to a negative value, or x and x gets bigger and bigger, a negative bigger, if that makes sense. So as this number goes to like negative 1,000, negative 1,000,000, negative 1,000,000,000, etc., 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 what happens to y? Well, we know when a negative times a negative times a negative, we get a negative. So this is going to approach negative infinity. We also know that as x gets closer to a positive value, so if I take this value and instead of plugging in a negative, I plug in a positive, so we go from 10 to 100 to 1,000 to 1,000,000, and we start cubing it, we also know that f of x is going to approach infinity. So this tells me that in this graph, this part here tells me that the function is going to start off negative. And this part here tells me that the function is going to end up going up in the positive direction. Okay? So this is what end behavior gives us. But we know more. We also know our zeros. Our zeros occur when x is 1 and when x is negative 1. Why? How do I know that? Well, one, you could just plug it in. But what we can do is, because these are quantities, we can set each of these equal to 0. So if I say x minus 1 is equal to 0, I get x to equal to 1. And the other part is x plus 1. So if I set that equal to 0, you get x equal to negative 1. But there's more to this story, right? Because this is squared, right? Whereas this is just x plus 1. Okay, so what happens is, depending upon the parentheses and the exponent, this denotes what's called multiplicity. Multiplicity. And what multiplicity here tells me is that this function is going to, or this value here is going to have a multiplicity of 2, which means that when we graph, wherever, I'm not sure exactly where 1 is, but wherever 1 is, let's assume that the function goes like this, wherever, well, hold on, if we're talking about 1, I guess I need to be here. So wherever 1 is, however it's coming towards the function, it will bounce off of it. In other words, it will, anything that has an even power is going to have a sort of bouncing effect. Whereas if it has an odd power, like at negative 1, it would cut through. Okay? So, again, I don't know what the picture looks like. I have no idea what the graph looks like. But if it bounces, it will hit and then bounce up. Whereas if it's an odd power, it'll just simply cut through. Okay? So, what else do we know? Well, we can also find the zero of the function. Okay? I'm sorry, not the zero. We can find the Y-intercept. So the Y-intercept, if our function is x, what is this? X minus 1 squared, right? Yeah, x minus 1 squared, x plus 1. All right, so if this is my function, then if I allow my x's to be 0, I can solve for y. And y is 1. So this means that this function has a y-intercept at 0, 1. Okay, well now let's put it together. So, what do I know? Well, my end behavior tells me from here that it starts off on the negative side and on the right it goes up. So whatever this thing looks like, it starts off negative and it ends on the positive. We know that our zeros occur at -1 and 1. So I know, and then we know the y-intercept is 0, 1, right? So it crosses at -1 and 1, and the y-intercept is 0, 1, so let's say that's right there. So if I draw this graph, I know it's going to go something like so. It cuts through here because x plus 1 has an odd, is raised to an odd power, and it bounces on the second one at 1 because x minus 1 squared is even. And there we have it. And so this is all that I'm asking you to do when you graph the functions. I don't actually know, for example, this function could technically go up higher and then go down. I just don't know. And I don't need to know, right? I'm not asking you to do that. All I'm asking you to do is to have an idea of what's going on there, okay? So hopefully that makes sense, and I will see you all in the next video.